On the unit circle, you have this arc, which is an arc whose measure is pi over 2. And it forms the central angle, which is pi over 2. And pi over 2 is a 90-degree angle. So this is the angle made from the initial side, and this is the terminal side where the angle ends. And on the unit circle itself, with a radius of 1, that's why x is 1 and y is 0, because it doesn't go up or down. Over here, this coordinate here, we know this coordinate is going to be x is 0 and y is positive 1. And if we go all around the unit circle, we can find, because the radius of the unit circle is 1 here, this on the x side is x is negative 1 and y is 0. And that is on, because this is the negative side of the x line, and this is the negative side of the y line. So considering this is the unit circle with a radius of 1, this coordinate here is x is 0 and y goes down to negative 1. That's the position on the coordinate graph. Now we're going to be focusing on this one. And I want to find the values of all of the trig functions at this angle. And this angle, remember, pi over 2 is equivalent to 90 degrees. If I was to take 90 degrees and I was to convert it to radians, I would multiply it by, and since it's going to be radians, the pi is going to be on the numerator and 180 is on the denominator. And just to show you that this is equal to pi divided by 2, again, I'm going to just multiply numerator times numerator. I have 90 pi. And this is over 180. And I can take out, I can factor out, or as some teachers say, divide or cancel out some forms here. But just so that you understand what we're doing is we're really just taking out the portion of the number, so to make it easy, is the one that makes the number 1. This is 1. And if we simplify this by 90, some teachers will say divide this by 90, divide that by 90. But the idea is if we divide by 90, we're going to just end up with pi over 2. So that's how we know that a 90-degree angle is equivalent to a radian measure of pi over 2. And so here is our angle pi over 2. And I want to find the sine, cosine, tangent, and all of the reciprocal functions for this at that coordinate. So let's say I'm going to find the sine of an angle whose measure is pi over 2. Well, if I'm going to look for the angle whose measure is pi over 2, then I'm going to look for the y coordinate. And the y coordinate is 1. So you can see that pi over 2, sine of pi over 2 is 1. Right? And I don't know why I write it so crazy, but whatever. The cosine of this angle, pi over 2 radians, which is equivalent to 90 degrees, and we say in radians is pi over 2, the cosine is the x coordinate, right? So that's going to be 0. That's going to be 0. And I know you hear a lot of this clumping and when I drop these things on. And here's the x coordinate, right? That's how we get 0. So the sine is the y, the cosine is the x. And then we finally have one more here, the tangent. Now we know that the tangent of pi over 2 is a ratio, right? Is a ratio of the y coordinate over the x coordinate. And if you can memorize that for the tangent, you're always going to put the y coordinate over the x coordinate. If I don't have to keep mentioning that, you'll know that you're going to get the tangent of pi over 2 is the y coordinate, which is 1, over the x coordinate, which is 0. And as you can see, this is undefined. So at 90 degrees, at pi is equal to 2, the tangent is undefined. So we have the sine is 1, cosine is 0, the tangent at pi over 2 is undefined. What about the other functions? The reciprocal of the sine, which is the cosecant. The cosecant at pi over 2 is equivalent to, and I'll just write it next to it just so that you remember, is equal to 1 over the y coordinate. And in this case, it's nice and simple because the y coordinate is 1. 1 over 1. And 1 over 1 is 1. So the cosecant is also 1. The reciprocal of the cosine is the secant. And the secant of pi over 2 is equal to 1 over the, remember, it's the reciprocal of the cosine, so it's going to be 1 over the x coordinate. And in this case, we have, I'll just slide this up a little so I have a little more room. We have that the 1 over the x coordinate, and the x coordinate is 0. So the secant is also undefined. And the last one that we need to find is the reciprocal of the tangent, which is the cotangent. The cotangent at the angle pi over 2. Now remember, since the tangent is y over x, the cotangent is the reciprocal, right? If you just remember it's the reciprocal, it's going to be x over y. So the cotangent at pi over 2 is going to be the x number, which is 0, over the y number, which is 1. So we're going to get 0 over 1. Well, this, anything divided by 1 is itself, right? So this is just going to equal to 0. So the cotangent of pi over 2 is really the same as the cosine. They both have the same answer. They're going to give us the 0. So we can find all of the 6 trigonometric functions at the coordinate on the 90-degree angle, or the pi over 2 radian, of the unit circle, which gives us x is 0, y is 1. All of them are the sine of pi over 2 is equal to 1. The cosine of pi over 2 is 0. The tangent there is undefined. The cosecant is equal to 1 at pi over 2. The secant at the angle of pi over 2 is undefined as well. And the cotangent at pi over 2 is equal to 0. So that's how we find on the unit circle all of our trig functions. Now, what do you think is going to happen if we had to find, I'm going to keep dropping things. If we had to find the sine, cosine, and tangent at this angle, what do you think will happen if we went this whole complete turn and we ended up at this angle is pi, right? Over here we have pi. Pi is the coordinate on this unit circle, -1, 0. What would all of the 6 trigonometric functions be at that point? And that's where we're going to keep investigating. We're going to keep investigating what would it be here, what would it be here, and what would it be here.